So there you go. See how it went. They're kind of fun, you gotta admit. A little bit.
I wouldn't say fun.
Questions on those? How did it go? So like I said, you have properties with exponents that you work with. You also have properties with logarithms you can work with. I want you just to write this down, and it'll make sense later when we talk about it. If you go from left to right, you are expanding. In the directions, when you do your homework, it'll say expand or compress. Expand usually means that you're going from here over to this way, from here to this, and from here to this. And if you go from this way, if you go from here to here, here to here, here to here, that means compress. They're interchangeable. This and this, they're interchangeable. Don't forget that. It doesn't just mean you can go from here to here. You can also go from here to here. That's what I'm trying to say with these properties. Okay, so they're interchangeable. So this is saying, well, we'll practice these. This is saying log b, when you have m times n, can be split up to add them, basically is what it's saying. And if you have these with the same base, you can put them together as multiplication. You can go either way. Sort of like the exponential property. Same base, you add them, right? Here, if you're dividing with the same base here, log b, you can write that as a subtraction with those two numbers. Here, if you have log b of m to the n, you can take that n and put it in front. Now these I could figure out and prove to myself. That last one I'm like, wait a minute, how does that work? So if you're interested at some point today, I have a proof for it right here. Okay? It does work. So if you want to see this, some of us have curious minds. I can show it to you. Or you can just accept that it's true. Okay? But we're going to practice all of these right here. So for the first part, they're saying use the fact that log 3 of 12 is equal to this, or approximately, and the fact that log 3 of 2 is equal to this. Okay? So we have to use those two things to evaluate the logarithm. So what we're going to do is keep in mind that they gave us 12 and 2. Keep that in mind when you're working with this. And you're going to say, okay, well, I have log base 3 of 6. How can I get 6 from 12 and 2? Divide, right? So I'm going to set it up like this. Log base 3 of 6 is really the same thing as log base 3 of 12 and 2, and I'm doing that because of what they gave me. I got to work with these. Okay? So, wait a minute. Is that one of my properties? Division is one of my properties, correct? Let's look at it like this. This is m and this is n up here. Do you see it? Yeah? So I can write that as a what? To help me simplify it, what can I write it as? Subtraction. So I'm going to take this and write it as subtraction. Log base 3 of 12 minus log base 3 of 2. How does that help me? Because they gave me the numbers. See, when they give you these numbers to work with, don't forget about them. That's what you're working towards. Now I can say, okay, well, log base 3 of 12 is 2.262 minus this one, which is 0.631. My answer is 1.631 for that particular problem. Again, keep in mind that you're always working with these. So let's look at this next one. Log base 3 of 24. If I'm working with 12 and 2, how can I get 24? Multiply. So I'm going to rewrite it as log base 3. I'm going to think of it as 12 times 2. And if I look at my properties up here, this could be m and this could be n. Correct? Two numbers multiplied together. So what can I do that might help me here? Yeah, when there's two numbers multiplied together, I can write it as adding. So I'm going to write it as log base 3, 12 plus log base 3, 2. And that helps me because I have these two numbers that I can add together. So I'm going to do that. 2.262 plus 0.631, and it simplifies to evaluates to this value right here. Doable? Let's do one more. 32. What do you think I can do? I might not use both of them. I might not use both of these. How can I get to 32? Can I get to 32 somehow with 12 easily? No, can I get there with 2? How? 2 to the power of what? 5 is 32. 2 to the power, so you have to think about it. So I'm going to say, okay, well this is the same as log base 3, 2 to the 5th. That's 32. Oh, well, look at that. That's this property right here. M is 2, N is 5. So what does this say that I can do then? I can bring the 5 in front. And that helps me because log base 3 of 2 is this number. They gave that to me. So I can say, okay, that's 5 times 0.631. And I can evaluate that to 3.155. So that's one type of problems you'll see on that worksheet. I think it's the first set. Do you see it? Is it the first set or the second set? I can't remember. Okay, so something like that. All right, now we're going to expand. Now when you're expanding, it usually means that you're going to go from this property over to this way. Okay? So expand log 3x to the 4th. Wait a minute. Is there a base on this? Okay, so what I'm doing is I'm multiplying 3 and x to the 4th, aren't they? So if I'm multiplying 3 and x to the 4th, which property am I going to use? This is m times n, isn't it? M times n. 3 times x to the 4th. I have two things being multiplied together, so I can expand it like this. So I'm going to write log of 3 plus log of x to the 4th. Now here's what I really would like you to do because it might help when you're going over this on your own. And I forgot to have you do this. Let's label these properties A, B, and C. And I'm going to kind of write the letter by the property that we're doing as we're doing these problems. So for this, I did property A. I don't know if that'll help or not, but... okay, so this I can't do anything else with. Can I do anything with this one right here? Is there another property that I can do? Which one? I can do property C, can't I? Because it's raised to the 4, so I'm going to rewrite that as log of 3. The first part doesn't change. 4 log x. And that's property C. And I can't go any further. That's it. That's expanded. I used all the properties that I could use. Yes? Yeah. Yeah. I mean, it's obvious. It's just like exponents. You're multiplying, you add, just like exponents. You divide. I don't know. I gotta consult on that one.
Just make it a little bit easier.
Yeah. You guys are, see, you're turning into whiners. I'm making you whiners. Making you lazy. Kelsey, you have a question?
Yeah.
This one here. Now, log base 7, and I have this divide, oh wait, it's divide, so start by subtracting. Okay? It's divide, so start by subtracting. So I'm going to say log base 7 of 3x squared, the top, minus log base 7 of 5y cubed. And which property is that I just used? B. Now be careful. Ultimately, you're going to be doing more with this, so you want to make sure you put a parenthesis around there because you might end up having to distribute a negative later. So it's always a good idea to put a parenthesis anytime you're subtracting something like that. Now, this first one, can I take this further? This is a 3 times x squared. It's a multiply. So I can expand that to adding those. So that's what I'm going to do. So I can take that to log base 7 3 plus log base 7x squared. The first term I can do that to. And then I'm going to write minus. Can I do the same thing to this? 5 times y cubed is multiplying two things together, so I can split them up as adding. I'm expanding this. That's my direction. Put it in parentheses. Log base 7 5 plus log base 7y cubed. That was property A. Anything else I can do? There's a couple of things I can do. What can I do? I can bring the 2 in front and the 3 in front. So let's rewrite that. Log 7 3 plus, bring that 2 in front, log base 7x. Now be careful, I'm going to do 2 steps here. I'm going to remove the parentheses, which means I need to make sure I distribute that negative to both of these, correct? So I'm going to write it as minus log 7 5 plus, is it a plus?
No.
It's a minus. Bring that 3 in front here because you can. So I did property C here. For this one and this one, property C.
That's stupid.
It's not that hard, though. Okay. I'm going to look at this and say I have to condense. Well, these two things are both ln, and they're being added together. So if I'm going from this way to this way, how would I combine them? If I'm condensing, if I'm going to go from this way to this way, I would put them together as a multiplication. Okay, so I'm going to do that. I'm going to take these and put them together as a multiplication, which would be ln of 8 times, ooh, I did 2 steps here. 2 steps. Should I skip that? Should I do the first step, or do you see how I did the 2 steps? Okay, let's do the first step. See how this has a number in front of it? I'm going to do property C first, and I'm going to make that the exponent on that term. So I'm going to rewrite it as ln of 8 plus ln of 5 squared minus ln of 10. So that's property C. I did that first. And now, since these are both the same base, I can combine them, because that's what I have to do for this. I have to condense them. And I'm going to write it as ln of 8 times 5 squared minus ln of 10. And that's property A. Okay? Now, let's make this pretty. What's 5 squared? Times 8? So this becomes ln of 200 minus ln of 10. Oh, I have a minus.
Are you kidding me?
Wait a minute, I can do this one. Property B. So I'm going to write it like this, okay? ln of 200 divided by 10. And look how pretty that becomes. ln of what? ln of 20. This is property C, or property B, is it? Yeah, property B. And you're done.
So much work for such a useless result.
Okay? It's really hard to get enthusiasm here, you guys. I'm trying.
It's just the worst subject.
Okay, let's do another one. What do you think would be the first thing, just like we did here, what do you think would be the first thing we would do on that one? Property C, where? In the middle term. The middle term. So ln of 4 plus ln of 3 to the third minus ln of 12. That's property C right here. Now I have an addition, so I'm going to put them together, just like we did this problem. It's going to be ln of 4 times 3 cubed minus ln 12. So this becomes ln of 108 minus ln of 12. Where did I get 108 from? Yeah, I multiplied these two things together, okay? And then it becomes ln of 108 divided by 12. I did not put these properties here. All right, so this is this. Yeah? So you have a portion on that worksheet of condense. This is what you're going to be doing. All right, change of base formula. Here it's just saying if you have log C of A, you can write it as a division. If you have log C of A, you can also use ln. You're not going to use this too much. You're mostly going to use this. Change of base. So this is how this works. Here I have log 6 of 24. It's the same as if I think of it like this, log C of A. What does this change of base formula say that I can do? I can set it up as log of 24 over log of 6, and do not say that's 4 because it ain't log of 4. Doesn't work that way. No, 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 no. That does not work. You're going to like this. Are you ready? This is not the same thing as log of 4. All you do is you use your calculator at this point to evaluate this. Log of 24 divided by log of 6. That's what Brian was saying yesterday. Yes?
How do you know not to use the other one?
It'll tell you. If you look at it'll just tell you what method to use.
Oh.
If you look at it, says use change of base formula.
No, but there's like...
Okay, let's do this last problem here. The Richter scale is used to measure the magnitude of earthquakes. If an earthquake has intensity I, then its magnitude on the Richter scale R is given by this function. R of I equals log of I over IO, and I'll tell you what IO is. Where IO is the intensity of a barely felt earthquake. If the intensity of one earthquake is 50 times that of another, how many points greater is the bigger earthquake on the Richter scale? If it's 50 times greater, we could think of it as 50 to 1. 50 to 1, right? 50 is the intensity, 1 is a barely felt. 50 to 1, 50 times greater. I don't know the numbers otherwise. I have to think of it like that. So if I use this function log of 50 to 1, 50 is the intensity, 50 times greater than the one that's barely felt. Log of 50 to 1. I'm going to write that. 50 times greater. I don't know the numbers, but I know this represents 50 times greater. So then, oh look, it's division. What should I do to this to help me solve it? is subtract log of 50. It's base 10, obviously, because it's not written. And then you go to your calculator, and it gives you 1.699 points on the Richter scale. See, all those words for a very basic problem.